at an exponential growth and decay problems. The first one says in 1985 there were 285 cell phone subscribers. This is important. This is our initial amount. So underline it and state initial. In the small town of Centerville, the number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? This is also important. For exponential growth and decay, you always start with your initial, which we're going to call A, times 1 plus or minus your rate. So R is your rate. If it's growth, you add. If it's decay, you're going to subtract. And then to T, which is your time. So we're going to fill in what we have. We have that 285 cell phones is our initial amount, which is A. So for A, we're going to put 285. Then we have our 1, and it's growth. It's increasing, meaning growth. 1 plus whatever our rate is. This is our rate is 75%. But we don't use 75. We need to put it in decimal form. So you can take 75 and you can divide it by 100, which gives you 0.75. You also can just move your decimal over 2 places, which also gives you 0.75. And then you raise it to T, which is time. But there's a problem. This is in years. It doesn't tell me how many years have passed. We've got to figure that out. So we take the year we're trying to look for, which is 1994, and we're going to subtract the year that started, which is 1985, and we get 9 years has passed. So our time, our T, is 9. Then we can put all this in our calculator. Remember, when you're raising up to an exponent in your calculator, you hit the caret key, which looks like this. And our final answer will be 43,871.99. Or you can round it up and get 43,872. So that's exponential growth for the first one. If it said the number of subscribers decreased by 75%, you would do the same exact problem. The only difference is this would now be a negative instead of positive. So in the second one, you're going to erase all of this. For our second one, it says, bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. That's important. If we start with only 1 bacteria, which can double every 3 hours, how many bacteria will we have at the end of 1 day? So we're going to need all of this information. We've got our initial 1. It says we're doubling it, so it's obviously growth. And then it's our T value. So our initial, it says it starts with 1 bacteria, so 1 is A. And then it says it doubles. And what that means is we're basically multiplying our initial amount by 2. So our rate is 100%, or 1, and so you get, remember, 100%, move your decimal 2, and you get 1. So if I put 1 where R is, you get 1 plus 1 gives you 2. So we're going to double this. And then it says, I want at the end of 1 day. Well, since we know it's every 3 hours, we know that 1 day, how many hours are in a day? It's 24. However, it says every 3 hours. So per 3 hours, and per means you're dividing by 3. So we're going to take our time, which is 24 hours, and we're going to divide it by 3. Because now we have 24 hours per every 3 hours. So then from here, all we have to do is we just put it in our calculator and we end up getting 256 bacteria. So triple, this number would be 3, and so on and so forth. So this is how you do exponential growth and decay.